So hi everybody, I'm Hans-Joerg from Rhein. I should have been here together with my buddy Robert, who runs the product line management of the things behind what I talk about. Unfortunately, he doesn't feel well, so he says hello to everybody. It's half the fun without him, but I'll try to make it at least a bit interesting and fun for you guys, also because this is right after lunch. And so I'm going to talk a bit about technology here and some background and try not to replicate what all the other speakers have already said, which I really appreciate because I'm all in for what I've seen today. I'm from Radisys. Radisys is, for those who don't know, we build close to the whole 9 yards for fixed and mobile networks, from the CPEs, handsets, to the IP handover point, including management systems and controller. We not only try, we are open. Open Radisys is an important part of our company philosophy, and that includes also standardization and community work, one of the reasons why I'm here. So, let's start with geography, and apologies a bit for what I'm showing. I was not aware that part of Germany goes on strike. But just to remind you where you are, you're in Mainz, right? This is where most of you came in, and I hope most of you fly out very timely. Really apologies for Frankfurt Airport not operating as well as I wanted it to be. This is where we are. This is Darmstadt. This is not only where I live, but I have a story around Darmstadt to tell. Yoshi-san, Kota-san, this is how you get to Tokyo, and I have a story around Tokyo. And no talk without the Silicon Valley. I mean, Ken, you will appreciate that, right? Yeah, but the Silicon Valley is half the fun without you, but still, I have something to say on this. So this is where we are. Welcome to Mainz. Looking back, now I'm really taking a step back. I want to explain a bit why certain things have been built in the industry the way, what was the idea, what came out of that, what have we learned, and how can we apply that to the future. And I take a really big step back, because there's one thing that I came across when I worked at NEC, and that was a very smart person in 1977, said the CEO of NEC at a conference at Intercom, I think it was in Atlanta. He basically said computers and communications is the same. Now most of you will say, yeah, no-brainer. But back then, just imagine we had all these analog telephones, and then there was something like computers where some people in the early 70s said there's a demand for 10 computers on this planet. He saw it coming. Computers, communication is the same. We do software-driven. We went even further with applying real IT technologies to the network, and the IT guys learning from the networking people. Been part of that in the last 20 years. Was a fun ride. So next thing in the timeline is 1981. 1981 was the release date of the RFC for the Internet Protocol specification, IP protocol, and we all build on that. And I'm still a strong believer what the biggest thing we deliver in networking is IP connectivity from A to B. As soon as we have that, keep it as simple as you can, don't overload it, work on solving problems where they are, but don't overdo it. I did a recent look at the IETF website. I appreciate the work of the IETF very much, but currently we are at 9,552 published RFCs. That's a lot. And back to NEC, they have a nice video on YouTube that basically said you've taken an old car and you've put a jet engine and somehow made it work. So the internet had been patched, right? If you click on this video from NEC, it's very nice explaining that. So we built something. The idea was very nice. You all remember the ZIP protocol, 3 messages, and the call is set up, and you all run IMS, right? And that's above 100 messages that we need today. Maybe we can get rid of some complexity. And that was the thought that a few people, and now we come to the Silicon Valley, had in 2008 when the Clean Slate Internet program was set up. And one child of the Clean Slate Internet program is OpenFlow, which basically means we can program the network. And that was the predecessor of what we now call SDN. And I'm giving lectures at university, and I think these 3 items here are key in what SDN means, at least in the original sense. First of all, we can program flows through the network. We don't need to just program one thing and then have all of them talk to each other and magically, like RSVP, TE, you can get a path through it. Why am I doing this if I have a central management control system that anyway sees all the nodes? I can just program a flow from A to B. That's one of the core fundamentals of what I think is SDN. The other thing is what's happening on the way. There are intermediate nodes. They are processing basically packets and frames. And the moment I can open them up, have the SDK or use OpenFlow and can program what these nodes do, I can add a new protocol at very short lead time. Example, adding GTP processing. If you have programmable data plane, that's not a big deal. So that is number two. And then, and that's something that I've seen in many of the other presentations about the domain controllers, we need interfaces to put our applications on top, northbound, to be able to run various applications depending on which customers it is, and southbound to be able to abstract away certain technology specifics. So that's the three fundamentals that I think is SDN. One more thing, when the OpenFlow protocol was designed, they also added a smart function, at least in my point of view, is there's the proactive and the reactive mode. Proactively means I know where the flow should go, but also if I just listen to what's happening on the network and the first sign of life from a device comes, that can be to trigger a ZTP process, but it can also be to trigger creating a session to example BNG in BBF. First sign of life, that was already there. And what you can do if you have the central controller, if you want to put a box in the way for some additional services, it's hard to do that with the IP protocol. I think it's still close to impossible, but if you have a central controller, add a rule here, add a rule there, just route the traffic through there, and you can add whatever you want. So that was the value proposition of SDN. 2012, and now we come to Darmstadt, where I live. There was the SDN, OpenFlow and SDN World Congress. That was, to my knowledge, the first time the industry hosted an event. That was when SDN got serious, in my point of view, when the industry really picked it up, and it was the starting point of ETSI-NFV. That was when the white paper was released. So on top of saying, we program the network, we make it open so that everybody has access to devices to program them, they said, hey, also the more fancy processing or endpoints can be put on generic x86 servers. I want to do a fresh look later on. So, but when we were there, and I was also at ETSI-NFV1 in Sofia Antipolis. I don't know if somebody's in the room who was there. It was snowing on that day. I can still remember that. Basically, the whole community said, let's put everything on service. Let's just service chain everything, magically connect them, use SDN to do that, use OpenStack and VMs back then, and just rebuild everything. We have all gone through a learning curve. A lot of that stuff has materialized, but not in the way that we thought when we met there in Sofia Antipolis back then. So today, I think the date is right, March, base seminar right after lunch. Where are we? We have a toolbox, and that toolbox looked different 10 years ago, because we've gone through learning curve 12 years later. Number one, what really matters, and put that on top, communities, standards matter. I still think that with the lockdowns, with COVID, not making us meet, talk, exchange on thoughts, that has slowed down the industry in developing open standards and moving on at the pace that it was before. I think we're coming back to this. I saw very packed rooms here at the BBF meeting this week. I'm very happy with that. Next thing, disaggregation. That was not a term that was used in the beginning when we talked about virtualization and SDN, taking things apart into individually manageable pieces. If you disaggregate too far, you have lots of pieces and you can't control them anymore. But separate the software from the hardware. We see that in the router domain, like you have bare metal switches, you put a NOS on top, and you can decide which NOS you use. You can pick and choose from the switches. That was not there when I started in telecommunications. Network programming. Yeah, OpenFlow allowed us to program packet processing, not to the extent that I would have liked it to be. Then P4 came up, but P4, also is there, but not widely used. So I think on the network programming, on opening up programmability interfaces to customers like operators or big enterprise customers, that has not moved at the pace that I was expecting it to do. AI and ML, I just skip because I've seen wonderful presentations on this today. APIs matter, and this is also a thing that we learned here also in the Broadband Forum. We have, for instance, for access networks, we have TR 413 that sums up which APIs are needed to be interoperable. Next one, decoupling. Decoupling I'm taking very serious. I have a bit of a software background, and I always try to make sure that systems that are designed where I have some influence in are decoupled. We come to that on a separate slide, but I just want to highlight here that separating concerns, not like building a big monolith that does everything and everything is tightly coupled, and if you do a change here, you have to do a change there. That is, in the beginning, it's easy to implement a tightly coupled system. The moment you go into maintenance and different life cycles, it will slow you down. Software-driven approach, yeah. It's not all software. Photons cannot be programmed. I have a PhD in physics. I think I know that. They do what they used to be doing many years ago. We had a good discussion about polarization mode dispersion. Remember that last night? Yeah. Okay, cloud technology and scale came in, and you saw I had OpenStack and virtual machines on that slide. I don't think you're still working with OpenStack and virtual machines. We've all moved into container land. We have Kubernetes that everybody's using. Fantastic open source project, hardened, working. Another thing is when we started the work, we needed small Kubernetes clusters with 3 servers, and everybody was looking at me, what the heck are you doing? Why 3 servers? Nobody needs this. Now, when you look at IoT, M2M, everybody has 3 server clusters, so we were a bit ahead of the industry, but now the community has picked that up. There's K3S, works like a charm. Automation, needless to say, if we put new things in, complexity doesn't go away. Complexity will always be needed to a certain extent, but have it under control and automate it. Also, very good talks here during this week. Telemetry is something that we really can learn from the cloud guys, from the big hosters that have developed things like open telemetry. It's all there. There's certain things we don't have to develop in the networking industry anymore because somebody else has done that. That's just good. Virtualization, no-brainer. But the biggest thing is transformation. I'm really serious about that. I went through transformation in at least 2 companies where I've been, where we were working on networking and software kicked in. Software guys came in and said, this is all wrong, what you're doing, it's all software. No, that's also not the case. So you need to find ways to solve real-world problems and to make sure that the organization you're in is also transforming into that direction without walking in and saying, you do the old stuff, I don't need you anymore, or you do fancy stuff and in 2 years from now it's gone. Finding the middle ground on that and steadily moving towards a common goal is the way that has worked, at least in 2 companies where I've been. So basically, Robert did a nice animation. Let's see if that comes up. This is what you know, right? This is a typical access network. It doesn't matter if it's mobile or fixed. You have the G node B, you have the access node. What we have done with disaggregation and virtualization, we have disaggregated these components now. For instance, aggregation network, that's a switch and a NOS. So if you want to build a state-of-the-art aggregation network for mobile backhaul, fixed line backhaul, you can buy the switch somewhere, you can buy the NOS somewhere, and it will work. It will work. And that was not there when I started in telecommunications. It's a bit like the computers, right? The IBM PC, and you can run various NOS on this. You can do that on all layers. You can also do that with the BNG. I'm partly guilty of that. I think that this happened, that you can put either on an x86 server, pretty good performance these days, or on a systolic pipe if you want the ASIC variant. For the BNG, there's not a do this or that. It depends on what your deployment is today and where you want to go. And then there's at least 2 technologies out there, and I think both have a reason to exist. So you can pick and choose. Now, when I say this looks pretty complex, right? Doesn't it? And it is. So the trick is that, and I saw a very nice presentation from Kurt on that, that you need to orchestrate that. Yeah, there's multiple domains. Don't try to do the God controller, the Uber controller, we called it a couple of years ago, that does everything, slice it into digestible parts, but then have an orchestrator so that we can control all these parts of the network, that we have a coherent service towards the customer. And I cannot walk in with this slide to my old friends from Vodafone and say, guys, rip out your old stuff, take this one, and in 5 days it's going to be working. You're going to kill me for that if you go down that path, because this, again, there's a transition. Start with something, start with a domain where the life cycle is close to requiring a new thing, and then let it grow. That's one of the learnings we had over the past years. Okay, so this is large-scale design to cost, you know all that. Now I said fresh, maybe I told you something you know. Let's look at some selected aspects of the ingredients that we need to get there. One of them is, I can't go here without talking about session steering, obviously. So subscriber session steering is a key work item in the ATA working group at the BBF, and I'm just briefly going to explain what that means. This is a real use case we've implemented. So if you have a distributed access network consisting of spine and leaf fabric, like you've, for instance, seen in the COID architecture, then you have decomposed the big router into smaller components that you can program, right? So you have, this is basically the leaf switch is like an aggregation switch, then you have the spine that's aggregating further and talking to the IP backbone. If you look at TR384, this is in there. I did the picture back then. So, and then you also have a handover point if you have wholesale, right? Multi-tenancy. So the question is, has always been, how do I configure the network? And now the network has become even more complex, because instead of one box, I see 5. That's where SDN kicks in. So basically here, this is a customer, and here you have your ONU, which can come from Radisys or from somebody else. But this person turns on the device, and the device boots up, and it ranges. And then you have a port up message. And that's what we call first son of life. And now I'm going back to the SDN principles, the 3 principles. And one of them is that you can program the path based, for instance, using the reactive mode. Something happens, I see, oh, something happened. I have information in that first son of life that I can correlate with what I have in my database. And this is what is happening then in the SDN controller. You do a lookup with the database, and then you figure out, oh, this serial number belongs to this person, it's this service. This person is served by another ISP, so I need a path. So, and I need to translate the VLANs, because this wholesale partner just uses a different kind of VLAN range. So I instruct the nodes to, whenever a frame with these characteristics comes in, I swap the VLAN, I program the handover point, and I use SDN. Go through the animation to program the path through the network. That's one of the use cases of subscriber session steering in BBF. It's not the only one. There's great use cases about redundancy to different BNGs, but that's another one where you can dynamically steer sessions to what we call a service gateway that can be, for instance, a BGP or a BNG or any other kind of IP termination node. Now, when I looked at this, we've built this, right? And then I was invited to go to the university to give a lecture about SDN, and I looked at it again, and I figured out all 3 core components of SDN are used when we do session steering. Because we program flows, we program the nodes, and we have a controller that is in charge of all that, that has a northbound interface, because as Kurt also said, who cares about which port this is, where it goes along? I want the customer to be handed over to my wholesale partner with that VLAN range. That's all I want to know, right? And the rest is up to the network. So let's shield that away, and if something breaks, we repair it inside there. But if I need to do a change in how we do the programming of the flows, I don't want to touch any IT system that's not in direct vicinity of that. So let's see where animation takes me. So when you look at this, this is basically a layer 2 tunnel. We all know that. For those who have done Metro Ethernet, it's like frames in, frames out, 2 points. But now I have dynamic control. This is not done in Excel charts. This is not like planned 3 weeks ahead. I can do that on the fly. Now, we talk about BNG, we talk about wholesale handover points. What if it was a UPF? What if I just use the 5G attachment protocols and just tunnel them on layer 2 to the UPF? Show me the AGF in that picture. I don't see it anymore. Anyways, moving on. I said, those are no Robert slides. They're nicer than the ones that I did. We coined a term when we built this SDN controller, and we called it the Las Vegas principle, which basically says what happens in the Brauhaus in Mainz or what happens in Las Vegas stays in Vegas. That was a funny way of describing a fundamental IT principle. That means decoupling. If I have an intent, I say I have an intent, there's a new device that needs to be brought up. I just tell the system, if you see this device, just wire it, configure the IP address, and let me know once it's operational. It's just the intent. Yeah? How you do the details, it doesn't matter. Let's not have OSS, BSS care about how many ports I have on a line card. If you have a dependency like that, if you get a new line card or a new switch that has more ports, you have to touch 5 different IT systems, 5 different organizations in worst case. That is not effective. So that is about bringing new devices in play. There's a meeting. I don't know if you need to go. Let me just see if I can get that. It's gone. Okay, the other thing is per service. So I have a customer, and I know that I have one customer that is connected from operator A, and he needs to go to operator B, but he needs this QoS profile, and this is the serial number. That's all we need to know. We just put the intent there. Customer comes up, first sign of life, and then we do the soft wiring, for instance, using session steering or having pre-provisioned path, however is best. The next thing is about telemetry, and I've seen, let's go back for a second and stay here. I've seen the Tiger team work, and finally I found some time to really look into what the BBF is working on inventory models, the stuff we do with IETF. I love it. Because there is this thing with inventories. Those who work for network operators, and I spent 16 years of my lifetime at network operators, you have your inventory, and then you have this thing that's out in the field. It's not the perfect match. Let's leave it like that. But if you want to build services that rely on exact knowledge, where the device is, how it's been wired, who's connected, 98% accuracy is the way to certain death, because you will have a lot of errors in the network. You need to have a real-time inventory. And I think the work that I've seen here with the Tiger team and at the BBF is basically you have a planned inventory, and then we have some animations here. So we have a planned device. We know somebody's going to drive there and put a switch in there. So we keep it in back of our heads. But then somebody goes there, and he or she physically wires it, turns it on. The device sends the first sign of life. If you authenticate, you authenticate. Then you match planned versus actual inventory. The inventory you have when you generate this is accurate in real time, and you can put services on top, because you only see what's really there. Really happy to see that picked up at the BBF. That is basically the explanation. And another thing is about telemetry. Don't look at the slide, please look at me. I spent some time in machine-to-machine communication. It's a huge amount of data that you can collect. The question is, do I need this huge amount of data at every stage in the processing? When we do AI and ML, okay, fine. The more data we have, probably the best. But in many cases, one of the tricks is which data should we drop, right? And when you look at open telemetry, there are means to have tools to implant in your system so that you can run some daemons and drop the data that is just redundant and you don't need it. Because I'm not selling storage on the cloud, so I'd rather say, like, drop some data and just keep the one that's important. This is how this works. I think that was also discussed at this workshop already, so I spare you the pains of me explaining everything here. Now comes the fishbowl. Now comes something different. And Kurt, that is not where I exactly agree to what you said, so you're saying this. It's we know that we build systems and we put interfaces around, northbound, southbound, what's inside somehow magically happens. We have an approach where we say, in certain selected cases, to our customers, network operators, it might matter what's happening inside. So the way we have built our domain, SDN controllers, however you call it, is based on microservices. That's a common IT principle. That's service-based architecture, stateless services. You have a database where you store the state. The microservices themselves don't carry state. If you need to clone them, if a microservice dies, it doesn't matter because the data is somewhere else. It's in the database, which is redundant in itself. So Robert, who unfortunately couldn't make it here, said this is like a fishbowl. So we made a fishbowl out of this. So basically, this is your IT system. You have, on the southbound, you have the devices. Northbound, you have them there. This is where you might get a bit stateful in the sense that sometimes you have sticky communications with radio servers. Then you have the microservices here, and then you have, in most cases, a message bus or a proxy that routes REST requests, and the central database. Now the trick here is, if you want to run a workflow, implement a workflow, you have all the data at hand. So if you look at the map, how we have built it, and I'm sure others have built it in similar ways, you have microservices, you have data models inside the system, and if you want to have a new workflow for a new type of session that shall be set up, maybe point to multi-point, or maybe to the evolved packet core, wherever, and I need some new modules. What do? I have all the data there, and this is, sorry for the high-level stuff here, but I thought like you add a new microservice, you throw it into the fishbowl, right? So it's part of the game. And this microservice listens to events that you subscribe to on the bus. So if the system receives a request, an intent, and the microservice has subscribed to this intent, it's going to do something and put a message back on the bus and a change in the database, and doing so, you can chain microservices and run workflows. Another way of doing that is also to do no-code, but no-code approaches generate these microservices. But let's look into how such microservices would look like, and this is generalized. I wanted to put the real example in there, but even in an empty Go program also already has a lot of stuff around that that's all the same, but it looks a bit blurring the message. So basically what you do is you import your stuff, you create some functions. For instance, if you want to do session steering and want to calculate a VLAN, you need your algorithm that you probably put in a method or function, and then you have function main, so you receive a message that you have subscribed to. Well, what do? It's like a Turing machine. You load some data, you do some computation, you write the data and return a message on the bus, but make sure somebody picks that up, otherwise it would be a broken chain. So this is how it looks from the inside. This is how we've built it, and that is maybe new. Might be new to some of you, some might know this. With our customers, there are different levels to engage with us, in the sense that we can give you the SDN controller and you ask us, okay guys, please make sure that this way of programming the network works. I want this VLAN range translated there, and they just test it. Fine, cool. Then the fishbowl is a way for us to efficiently implement that. There are other customers, and I used to be on that level in one of my occupations, where the customer says, okay, we've got the algorithm, but I want to see how you've implemented it just to make sure it's functionally right. I've done that many years ago, looking at the code. So that would be a level of engagement number 2, where the customer says, hey, I want to look one level deeper into the system. And the third one is massive co-development. With one customer, we call that hyper-collaboration. It means we bring along the system and we work jointly on that. That's the ideal case. That only works in larger deployments, because the subject matter experts from our customers join our experts that do development, and they build it together, all in microservices. So there's multiple ways of levels of engagement. We'll see where the future takes us. So as said, we have customers that pick one of these 3. I personally hope this level 1 is, I think it's the most fruitful one, but customers need to have reached a certain level in their transformation journey to be able to join the development here. Voila. So I'm coming close to the end of the talk. This is the picture you've seen. A few statements here that we separate the software from the hardware. We're strong believers in using SDN as it's been developed over the past years to finally orchestrate and automate the networks. Pull the business logic out of dedicated functions, because if I put the business logic into a certain function and I want to go second vendor with that function, I have to develop it again and again and again. But if it's in the fishbowl, if it's in the microservice, simple example, VLAN mapping, do it only once. If I want to change it, I change that microservice, and it's going to work on all nodes, whatever vendor I'm using on the southbound. Communities. We're here because of the communities. I'm happy to be part of the community. Few things here. After this week, I would put even more Broadband Forum logos on it, but there's a few things that I want to highlight. The Cloud Central Office, the session steering, which I'm co-editing together with John from Vodafone. The whole thing about the young data models, about the OLTs, also disaggregated OLTs. Sorry, Antonio and Francisco failed to put that on. The next version of the slide will have it. TM Forum, processes, IT experts, yes. Linux Foundation, we will have a talk later about the Volta framework. I skipped that here because why should we repeat things? Tip OpenBNG, yeah, hi Mario. So, what's next? So I said fresh look, let's have a fresh look. And you're all coming from lunch, so let's have a fresh look and look at vegetables and fruits. And so what's the bottom line here? What do I would like you, what would Robert and me would like you to take away when you hopefully board an airplane soon or drive home or enjoy a nice city of Mainz? There's a few things that would like to implant in your heads that you might want to think about, and we can talk here at the forum next time we meet or in some other places. Out of the box thinking. So SDN was really some crazy guys in Silicon Valley that said, if the internet wasn't there, how would I build it? Taking a step back, looking at what you build on a daily basis, rethinking, if it was from scratch, would I still build the same thing? Is a valid question. I'm not saying that it shall be then built along the clean slate approach, but if you don't take this approach, you maybe lose good ideas. That's another reason why I enjoy working with the universities also, because they don't carry these 20-something years of backpack in the industry that I have with them. The learning curve. We've seen good ideas die on the path. OpenStack's not that widely used anymore. I thought programmability goes further. I also projected that we have BNG APIs already. We have control plane, user plane split. Yeah, that's on the way there, getting there. But I thought we would be going a bit deeper. The industry has not done that. So we learn. Another thing that I also would like to encourage you to think about, there are certain things that just didn't make sense or didn't work 10 years ago. And you put it into your drawers and said, done that, been there, seen that, doesn't work. But technology moves on. One example is the merchant silicon-based BNG. I tried that in, I think, 2012 or 13. It was awful, it didn't work. And then picked it up when the chipsets were there. The ideas still remained. And now this works. Next thing is re-ask yourself, am I really solving the problem, or am I just keen on a certain technology and I want to drive it to have the technology instead of the problem being solved? Still on the fresh side, programmability is a bit red here in the sense that my prediction on programmability had been wrong. It hasn't advanced, but maybe it's time to pick that up again. Go one level deeper and have customers, so our customers, the network operators, enabled to program their devices. Because they know what they want. They can go, they take a system like this that's programmable, they can test drive in the lab without even me knowing it. And they can do the first steps, and you can rapidly prototype. Like in computers you could always do, and see if a certain thing works or not. Abstractions and APIs, I'm preaching to the choir here. There's room for improvement because interoperability is more than just referring to standard APIs. netconf Young is cool, but Young is a modeling language. netconf is a protocol. What matters is the model. That's why so many skilled people meet here to agree on the models. Think in software. That's another thing that you've seen the fishbowl, you've seen the microservices. Having worked mainly in the domain of network engineering, but having a bit of a background in software, looking at what has happened there, looking at the different architecture patterns and how software is being developed, the whole CI/CD thing. I had a discussion with Hagen recently on nightly builds, proving that next morning we come to the office and we've seen that if the idea was really a good one because we have run all the tests overnight. That's such a powerful tool. Next thing, communities matter. I'm not saying this because I'm here at BBF. I'm strongly believing in that. That's why we're at the forum here. And I think I'm nearly done. This is another thing. We add good stuff, right? We also add complexity. Especially to the network operators, have a plan how to get rid of that again. Because if you just walk from one technology that might age into another one and you don't have like at least a rough view on how to manage the life cycle and take it out, that might cause some troubles. This is one of the reasons why I'm personally also keen on disaggregation and spine leaf fabrics. Because if somebody comes tomorrow with a super duper programmable switch that nobody was aware of that it's there, you might just add it on the leaf layer and keep the spines as they are because you have disaggregated. So you can selectively put out things, and that's another thing where session steering comes in handy. If a new system comes around, I just theoretically need to steer the traffic there without having multiple vendors reprogram their boxes. And I think this is the last one. This was supposed to be a bit more like inspirational talk. Let's keep on innovating. We have all the brains here, and there's much to do. I've seen pretty cool stuff here also outside of this room. Let's keep on innovating, and we're building. When my kids ask me, "What are you doing?" It's like, Mom and Dad are part of these people that built the internet, and they know what the internet is. They like it. It's cool. So let's do that. It brings people together. That's the Radisys logo. I go back to the fruit and vegetables. I hope I didn't run over.
It's over a little bit, but and I think what we'll do is, if you have questions, why don't we hold them, and what we'll do is kind of collect them at the end. We'll see, how we are at time. We're supposed to end at 3:30, but obviously if we go over, if everyone's engaged. But it's appropriate that you're building the internet here because the Gutenberg Press was right here in Mainz, right?
Yeah, but I'm not relative of him. This was done.
Oh, yeah, but it was the internet of the day, right? So Hans, thank you very much. That was very good, and it was enlightening in terms of where this is going. So, yeah, thank you. And